Hey guys, so today we're going to be looking at simplifying some radical expressions. In this case, we have the square root of 12 times q to the 4. So one thing to keep in mind before we do this is I know a few properties already. One of them is the square root of two numbers multiplied together is the same as the square root of the first number times the square root of the second number. The other thing that we know is the square root of some number squared is just equal to that number. So over here, let's go ahead and let's start breaking this up. So I can start thinking of this as the square root of 12 times the square root of q to the 4th power. Now we don't know what the square root of 12 is, but to keep it in radical form, we need to break this up into two square roots. And I need one of the numbers that I'm breaking it up into to be equal to a perfect square. So are there any factors of 12 that are perfect squares? Well, if I think about my list of perfect squares, 1, 4, 9, 16, 25, and so on, we want one of these because I'm using a square root, which will give me a whole number. So in this situation, 12 can break up into the square root of 4 times the square root of 3, and then times the square root of q to the 4th. And this is where everything starts getting simplified. Because the square root of 4, I know, is just 2. The square root of 3, well, that can't be broken down further, so it just stays the square root of 3. And then the square root of q to the 4th. This is where it's really helpful to think about what is a square root. Right? A square root, instead of writing the square root of q to the 4th power, I can think of it as q to the 4th power to the half power. So if I know my product rule, which I'll put a link to in the top right screen right now, I know that multiplying these two exponents is how I'm going to simplify this. So that is going to leave me with q to the 2nd power. And so now I can just rearrange everything into the right form. And so my final answer will be 2q to the 2nd power times the square root of 3. Now, you may know the rule that if I have an even root, then my answer is always going to be an absolute value notation. So if I had the square root of x to the 6th power, technically this is x to the 3rd power. But here I write the absolute value symbols because it's possible to get a negative answer here. And this can't be negative. In this situation, q to the 2nd power always is positive, so I don't need the absolute value symbols here, and this is going to be my answer. Okay, let's look at one more. Here we go, we're going to separate right away. I like to break everything down as far as I can first, and then simplify. So I'm breaking it down to the square root of 75 times the square root of d. Now I need to break up 75. Well, can I break up 75 into two numbers that multiply to get me 75, but one of them is a perfect square? Give you a second to think about it. 25 and 3. We know 25 is a perfect square. That'll be 5, and then times the square root of d. So the square root of 25 is just 5. And then now we can write this all as one square root because these can't simplify down any further. And so my answer is the square root of 3d. And this is going to be my final answer. All right, let's look at one more slightly difficult problem. And here we have a more complicated looking one, but this really doesn't do anything different if you break everything down first before you simplify. So I'm going to separate everything into 4 times the square root of 12 times the square root of m to the 9th. And now I'm going to break these down into perfect squares if possible. So 12 we already dealt with before. That can be the square root of 4 times the square root of 3. This is going to be a more complicated one. So what we're going to want to do is we're going to want to separate this into two square roots. And what is a perfect square here? What's a nice one that the square root function is going to behave easily with? And it's going to be any exponent that is even. Any exponent that is even, and here's why. I'm going to write this as m to the 8th times m to the 1st power. Those two would multiply to get me m to the 9th power. You'll see why I wrote it this way in a second. So here we have 4, and then the square root of 4 is 2. So 4 times 2 times the square root of 3, and m to the 8th power. Remember, let's have that thought bubble again. What is a square root? Well, it's really, instead of writing the square root, you could write to the 1/2 power. And so this is why we always want this to be even, because if this is an even number, then when I multiply it by 1/2, it's going to get me a nice looking exponent. So what is m to the 8th to the 1/2? Well, that's just m to the 4th power. And again, normally I would put an absolute value symbol here after doing an even root square root. But because the exponent that I'm left with is also even, this can't possibly be a negative function, so the absolute value symbols are not needed here. So it's just times m to the 4th power times the square root of m, which is just the square root of m. And so now again, we're going to simplify things down. Let's simplify 4 times 2. That's going to be 8. And then we're going to bring our numbers out of the radical up in front. So m to the 4th power goes up here. And then the square root of 3 times the square root of m, well, that's just square root of 3m. That's just reversing the property that we did at the beginning. So this may not look very nice, but it is our final answer.